I have two agendas today. One is offering the pattern counter create as a static library for a REST client. So before we offer this pattern counter create as a dynamic library so that any language that has a capability to load this dynamic library like Python, Ruby or C can avail its service. But before doing that, let us offer this to the REST client. And we can first have a look at what is a static library. Then we will promote ourselves to appreciate the dynamic library. Join me. So this is a pattern counter crate that what we left yesterday, and that has a target where we know that the libraries and the executables will be get stored. So now we will remove this target to see what happens when we build this pattern counter in a close-up shot. There is no target, and I use this cargo build -release. This is probably, if you have already watched my using Rustep toolchain and the cargo manager to do the cross-compilation, otherwise please watch this before you are further continuing this episode. So this episode is going to be full of creating different flavors of the pattern counter library that requires some basic understanding of the Rustep toolchain and the cargo package manager, and I have already offered an episode on this. So we are going to execute now the command cargo build -release. Okay, so release, and it is optimized. Let's have a look at what is there in the target now. So I created the target folder, and that has a release directory. And you are seeing here a library with an extension .rlib. That's a lib pattern counter .rlib. So this is the equivalent of a static library. So if we have seen in other examples, lib type equals rlib or dylib or cdylib, then what they are telling is the different flavors of the library. So this is the static library. So when you are not providing anything in this cargo.2ml about the type of library, by default it will assume that you are going for a static library. So now what we can do with this static library and how we can integrate this library statically to another client. So let us create one more project, and let us make that project to consume this library the same way that you consume many other dependencies that what the Rust community is offering you. For example, if you are consuming a diesel, or if you are consuming another famous thing like Tokyo or Actix, all of them are instances of crate, and the great Serde, that is to serialize and deserialize the JSON, and you probably would have seen a lot of dependencies in the long run. Now we do not have any dependencies, it is more of a empty dependencies. And now in the project that what we are going to create, we are going to have our first dependency that will point to this lib pattern counter.rlib. And how to do that we'll first see this, and this is called statically linking this lib pattern counter. Okay, so let me create one more project. So I am in this directory _, that has our pattern counter, and let's now create one more project, cargo new. Let me call this as rlib client so that you can correlate that in your mind, or have that in your, register that in your mind, that we are going to do something with the rlib. That is a Rust library. So it has just created a rlib client, and what it does is it has told you that it created a binary. So when you are creating this pattern counter, probably you can remember that we provided cargo new hyphen lib, and then the package counter that result in creating a lib.rs. And whenever you are creating a cargo out of that, it is creating a .rlib. Now we have the rlib client here, and this has a main.rs, and let's get into this rlib client. And this rlib client is now going to use this pattern counter, the create pattern counter. So we have to point the pattern counter here. So how to do that is, this is a cargo.yml of rlib client, and this is a cargo.yml of pattern counter. Now we do not have anything to do in this cargo.yml of pattern counter. Let me just close this, and I'm having this cargo.yml of this rlib client. And in this dependency, I'm just going to tell that where this pattern counter is. So the dependencies, what we can provide is, we will tell that pattern counter, and where the pattern counter is, we'll just provide something called as pattern counter. So we have already started seeing the signs of error now, and let us try to build or run this with a build this with a verbose to see what the suggestions that we are receiving from the system. Pattern counter for dependency pattern counter. So we know that we are acting. So let us try to provide some number now. 2.0. Now we are getting some more decent suggestions from Cargo that it is attempting to looking for a library as a regular crate that you used to get it like Actix or a Serday from the central registry. So now we will provide the actual path of this pattern counter crate, that what we have created earlier. So when we are providing the path for this crate, it is sufficient that if you provide this up to the parent directory of the project, and we not to provide until the /target /release, etc. So literally the parent the, the pattern counter is the directory where the cargo.yml lives. So that is what we are pointing here. Now we will try to rebuild this to see what happens now. I remove the target to show you the result of this operation. So now you can see that it is comparing first the pattern counter followed by the rlib client, that what we have created now. So we'll again do that by removing that target by providing a verbose so that we can see the internals of the compiler messages. So we can see there that first it compiled the pattern counter, and this pattern counter will be used as an -extern in the subsequent compilation activity. So this is literally the statically the pattern counter is cooked into, like every crates, into the rlib client. So that's what this -extern means. I allow this for you to look into this to see if there is any other thing that we can internalize in our memory. Fine. And now what we can do is, let's start use this crate as we normally do in several locations. Use pattern counter, and then we are referring to that frequency. Now you can see that the absence of any errors is an indication that the linking, that is the static linking, is going perfectly. Now deliberately I am providing a relative path here of the downloads where I have this class.txt, and we look for the famous wind pattern, and the result, you know that it is an enum. If it's an error, it will be an IO error, and if it is positive, and we will get the actual result, which is an I32, sorry, U32. So being an enum, let us print that with a question mark. And let's see if it is giving any errors. As I have provided a relative absolute or relative path here, this rather it's not a relative path, rather I have used some Mac custom of /. So I'll try to see where this downloads in my system so that we can provide an absolute path to see the result of the operation. It does not mean that it won't accept relative path. It will accept the relative path if it has been provided in the proper way, but till this not it is supporting. Yeah, fine. So this is a super simplest way for two host components to interoperate, and let's quickly modify this client now to accept parameters from the command line so that we can test different patterns from this file. So we'll start with the file. We need a file, and then we need the pattern, and let this file be the first argument. I'm writing that in the reverse order, and so these are the arguments that I am expecting from the command line. And how to get this arguments? Okay, so the way to get this argument is this stdenv has a mechanism to give us the args, but this is more of an iterator. So what we can do is that we can simply put a collect here to convert that into a vector. Okay, the collect requires, as I told already in some moments before, that how to, we have to provide a type for this vector of string. Yeah, so this way, this args, which we can use it in a for loop. It's an indication that that is having an into iterator already implemented for this, and you can use the collect method on this to convert this into a vector of string. So this way you can convert this args to a vector. And that's clear? Fine. So let us do a simple validation. If args length it is not equals 3, because the 0th argument is the command itself. So the argument length is not equals 3, we can just print length usage. What is this? This is a rlib client, correct? Rlib client, and then we can inform the users to pass the and the pattern combination. So this is a simple help message for people who are blindly using this thing. We'll quickly check this whether it is working. So go run. Okay, usage rlib client, file name and a pattern. So cargo. Let's go to the place where we have this table. Now we have this rlib client. You know that we can use it. It's a simple command. In fact, this is a way we normally, when we offer this client to any target environment, there won't be any cargo for us. We are going to invoke that as a command line option like /rlib client. So that is telling us the usage is rlib client file name, and it is not supposed to go to the next line. And I don't want this panicking here. So what we can do is that once if there is an error here, it is because we are just checking this and we are letting the control to go here. We will simply provide a return to this, and this won't get reach here. So cargo build. So that will create again another new rlib client here. So if we run this rlib client without any parameter, it should just tell the usage alone. Now let us check whether this rlib client is accepting of parameters. That is, it is in the class.txt, and then let us ask for lamp. Yes, this is working. So there is no fun here so far. This is what you have seen already. Now it is time for us to cross-compile this component and deploy this into a Linux box. Now the fun is going to start. Okay, so if you already watched the cross-compilation episode, I recommend you to watch that. What we will do is we will create a new folder that we will call this as cargo, and within this cargo we are going to have a file config. So in the config we are going to inform what is the linker I want to use it for. So how it is going to be target, if it is x86 64, if the target triple is x86 64, vendor is independent, and if it is Linux GNU, then so that is a Linux box. I am going to drop this SSH so this is a Linux box, and what you can just do is that gcc dump machine, then it should tell you that and it is a Linux box. You can also do this with the gcc -dump machine, I believe. So yes, so this is the triple target. x86-64 is the in your ISA, that is instruction set architecture. Red Hat is the vendor and Linux is the operating system. Now we are not having any um, per vendor configuration here. Unknown is an indication that it is independent of. It is not the vendor is unknown. And okay, so this is the place I am going to deploy it. Let me create a mkdir. I have already a so this is the place I am going to have all my artifacts I am generating for this session will be stored, and it will be used for checking whether it is working and what is a byte size, etc. So we will come to that as and when it is required. So let this Linux box be available for us for the play. So I am now I have provided what is a target triple for this, and then I have to provide a linker, because the linker that what Cargo offered by default, I mean the toolchain is offering us for the default, is not adequate for building an executable for this particular target. So we are suggesting a different linker for this. So which gcc, so user /bin/gcc, so which x86-64 unknown Linux GNU GCC. Yeah, so we have to use the GCC that what is coming along with this in my system is not supporting this thing. So I have already browse tapped to a different location, and I have browse install this unknown Linux GNU CC. And you can, how to do this, you can again refer to the cross-compiling Rust program episode. So this is the GCC I am going to use. For my purpose of creating a Linux executable, that is the result of the executable will be a .elf format. So this is our next exercise. Now we are going to just create a statically linked client or the rlib client, and then we are going to deploy this in a Linux box. So this is also an opportunity for you to have a quick recollect of the Rust cross-compilation. Okay. Fine, and to show to the audience, let me remove this rm-rf target, but Visual Studio will create this immediately, because it needs this to do certain things that is easy for you to infer. So I have removed this rm-rf target. Now let us do the regular thing, cargo build -release. So when I have this, it is creating an optimized version, and that will be available in the regular release directory. So if you go to the target again and the release directory, you are having this rlib client. Okay, and if you are wondering why this is too big for you, then probably what you can do is that you can strip rlib client. So this will remove all the unused constant symbols, etc. So your rlib client is somewhat become very small in size, but still, in my opinion, this is too big for us. And let us get into those size optimization later. So now the one that what I request you to observe is, when we are doing this cargo build release, create directory target, and within the target you will see the release. Okay, so now I am going to do a different thing. So I will also show you this again. Okay, so cargo, let us try a verbose build. What is it? Hyphen release. So this is a release for the current target triple, which is nothing but, as I am using my an Apple machine, so the target triple is the default target triple of this machine, and we cannot provide it here, so it will do its own compilation. So this is a macro format. So what it did is it first compiled the pattern counter and have it there, and then it used this pattern counter for this rlib client, right? Cool. Now we will do the same thing for a different target. And clear this. Cargo hyphen b build hyphen release hyphen target. Now we are going to give what is the target name here. So when you provide the target differently, so you can create an executable suitable for the target. Okay, RELGIS. Let me clear this and then REL. Okay. So now what it does is, it again did the same thing, and it created pattern counter. It used this pattern counter as one of its dependency. So in order to do that, it looked into your cargo.2ml, and this is of this cargo.2ml, where you have defined the dependency as the pattern counter. So it will check whether it is inside available in the same URL. It did the compilation, then it is using that to statically link that into the rlib client. Okay, now let us have a look at how this has been created in the respective directory. Okay, so this should be in the same target, and now you are seeing along with this release there is one more directory for this particular target triple, and if you get into the release of this, what you are having is an rlib client. So if you find this very difficult to see, let me just go to the same place, KRS code, and we are in the rlib client. So the target, so this is a tree structure of the target, and I'm getting into this x86-64, and this has a release directory, and I'm getting into the release directory, and what you are seeing is rlib client, and this is rlib client that what we are having for the Linux target. And if I run this Linux rlib client, it is supposed not to work here because it is for a different operating system. Okay, so the exec formatter is indication that this is the executable is not in the not in the macro format, it is in the ELF format. So now we will SCP this rlib client to the Linux box and check whether it is working. Okay, and SCP this rlib client, I'll put that into colon, and what is this directory? This is a Linux and this is a Mac. On the left hand side, what you are seeing here, this is a Linux box. Okay. /root testlib. Okay, there's 2 slashes. Sorry, I have not provided the .com there. Sorry for the confusion. And now I will again open a Linux box. SSH into this So the rlib client that what we have sent from here is available here. So if you want to check, this is 3282776, and let us check whether this 3277 82776 is tallying. So now if we run this, so this is working. So how am I saying that this is working? It is at least printing this usage. And if you want to really see that it is really working, and let us see the so that we got the class.txt, we lost this time to use the class.txt, and then we lost for our famous wind. So it's printing 163. So we quickly created and executable for a Linux target, and we saw it's an opportunity for us to see how the cross compilation here is also working. So it's a reckoning session for us. Now it's time for us to get into the second aim of this episode, that is a dynamic linking. Okay. So now, as usual, we are going to do some series of experiments here. And please note that this may lay the foundation for many of your future works that includes language, interoperability, WebAssembly, toolchain, and deployment, DevOps, etc. So this is going to be a precursor for the next episode that involves consuming the pattern counter, that what we have created here from a Python client. So the reason why I am delaying this entire process of just writing 2 lines of code and invoke from Python a Rust client is that won't give that much amount of insight into situations when you are encountering problems. So the real life is not going to be a cakewalk. There will be a lot of surprises. So you will get a lot of errors. So whenever you are getting into errors, this will equip you to provide the right solution for that context. So now it is time for us to make this pattern counter to give us a dynamic library. So again, I am reiterating that this is the concept that you will use in your WebAssembly. This is a concept that you will use in the forthcoming sessions of invoking interoperating with a foreign client. So if you have this, then you can deal with any language for that matter. It is not just Rust, but with anything. The underlying principles are the same. Okay. So now what I am going to do is I have to just prepare this, give a crate type. So how this crate should be? By default, it is an rlib. Now let us provide a crate type equals a dylib. So that is, I am going to mark this particular library to be used. The preference is it should be a dynamic library. And also please note that you have to have the rlib as well, because this is required in case if someone needs this as a static library. And mainly you go for a dynamic library when you don't want to duplicate the same logic across your OS. And if you want to share this particular library with many other clients, then it makes sense to have this as a dylib. So you can prefer what kind of a library it is required for that situation. For other situations where you don't want this to be a dynamic library, but I want this to be as a static library, by the time you continue to provide this rlib. So you can use this in what, so it's more like a switch. You can pass some flags later that what is your preference. Do you want this to be a static or you want this to be dynamic? By default, it is static. What is the effect of putting a dylib here? So when you put a cargo build -- release, sorry, I'm again doing the same mistake. Cargo build -- release. Okay. So if you go to the target now, so that will have the release, and you can see a different breed now. So in addition to the rlib, what you are having is a .dylib. So this is a dynamic library meant for our macOS. For Linux, what we are going to do is we are going to create a folder again, and that is going to be a .cargo, and within the .cargo we are going to have the .config in the same way that what we have for this rlib client, .cargo config, and if you put it here, what it is going to do now is it is going to create, when I put a cargo build -release -target of this, it is going to create a .so file, which is nothing but our Linux shared object, or it is a Linux equivalent of a dylib or a .dll. Okay, so let us see what happens if we provide this config and do the cross compilation of this shared library. Cargo build okay, let me put -v also here, build -release target. The target I am going to provide what is provided after this target. Remember again, this word target triple. Oh, sorry, the name of the file is not .config, it is config. Okay, now let's run this again. Cool. So don't worry. So the errors that what we normally will do is just a simple mad mistakes that we can easily overcome. And if we look into the target directory, that should have this x86 unknown Linux GNU, and that is going to have a release. And if I get into this, and you will see a .so file. In addition to that, you are having a .rlib file. So this is a way you can create a dynamic library. Fine. So now we have this dynamic library. As the name suggests, how are we going to dynamically link this with another client? So let us create one more client. Let us call this as a dylib client, and then we'll check the challenges, and we will encounter many challenges over there, and then how to overcome those things. Okay, so now you understand that the .so file is equivalent of .dylib. Okay, so similar to the rlib client, we will create one more thing. So probably you can notice here, so whenever you have provided this rlib client, let us just look into the two config.yml of rlib client and this. This is a cargo.xml of this rlib client. We have not provided any dependency. Here we have provided, sorry, we have not provided any crate type here, but here we have provided a lib. So if you have not provided any lib, and if you write everything in your lib.rs, Rust intelligently takes this and assume that it is a library. And whereas in the rlib client, if you have a main.rs, then cargo intelligently takes this and creates a executable for you. So those are the simple inference it is making from your cargo.yml. So in the lib, whether you are providing a bin, it will be converted. So then it will expect for a main.rs. If you are not provided a bin, but if you provide a lib, then it will wait for a lib.rs. You have this in your mind, and now we'll go and create a dylib client. So, okay, to this directly rather than .cd. So this is a place where we have a pattern counter and rlib client. So let us create one more thing, cargo new. You are not going to create any lib, but rather an executable. So we can directly put cargo new dylib client. So if you provide -lib, then it will create a lib. So it has created a binary application for you. So let us get into the dylib client. So it has an src. We'll play with that here. So this is our famous hello world. So if you execute this thing, it is going to print this hello world. Okay. Links here, and let us use the word pattern counter. This is a name that I am providing here. So this will start complaining you that I do not know what is this pattern counter. Failed to pass manifested cargo.2ml. So meaning it is asking you, where can I find more details about this pattern counter? Okay, so the next is there are two ways in which you can inform the cargo system to find or to search for where the pattern counter is. One way is you have to create a build.rs file in the same place where you are having your cargo.2ml and inform there what is where you can find this using some search path. Another way to do this is, as usual, let us go with a regular cargo and config operation. .cargo folder and config where we can define where you can find the respective artifacts, that what I mean here as pattern counter. So first, anyway, we have to first create a new file called as build.rs. And in the build.rs, don't do anything, just to create a main and just leave this. Okay, this is required as this is how the cargo works. It is not there is no logic here. This is what the cargo needs here. So you are going to create a build.rs and you are not going to do any configuration in this. But primarily this build.rs has been created to provide any inline configuration here, but we are not going to do that now. We are going to follow the same technique that what we did for this rlib client. We are going to create a folder .config, that's .config or .cargo, the same way that I am having is a .cargo, within which we are going to create a file whose name is config. So it is in this config I am going to inform what this pattern counter is. Okay? What this pattern counter is, and where can I find the shared library for this pattern counter or dynamic library for this pattern counter. So let me start first to define where I can find the pattern counter for this Mac machine. So what is it? I have to provide where I can find this dylib. Got it? So it is in the pattern counter target release here. If someone is giving you dylib, then you have to just tell that where to find literally this dylib. Okay? So the first step is, let us create as usual target. The target is, the idea is, it is a dynamic linking. So the target is, if it is x86 64-bit, if it is an Apple .NET, for example, if you put here as a dump machine, this is x86 64 Apple Darwin is what we are going to provide. There is no need for us to provide the other versions here. And if the target is x86 64 Apple Darwin, and if it is a pattern counter, that is, now if the cargo.2ml URL is the pattern counter, and we are giving where to find the pattern counter for this target x86 64. So where it is, we have to tell that using a parameter called as rest c -link hyphen search. So you go to this particular place and find and search here. That is, you have to provide the directory, and then the rest say link lib equals in what name you can find it. So this is lib pattern counter dot dylib, or if it is a SO, that is going to be lib pattern counter dot SO. So this uh, appending a dot SO, prepending with lib, all these things Callaway will take care of. You will just tell what is the name. That is what it is. It is just a pattern counter. So you are defining what is the name of the library here. It will do the required operation of adding a lib in front of this thing and adding a dot dylib after this, that is appending after this or prepending here. So the position of this thing is, it is in the input. So let us provide an absolute path for this, where it is. So if I go here, so this is an rlib client. So let us go to the so this is for this Apple machine. So we need not get into this x86 64. So this is available in this directory. So I will just copy this and then put that here. So now our configuration for is this. The Apple Darwin pattern counter is available to this. And where we did that is, we did that in the cargo.yml of the dylib client. Now, probably you have seen that the error is gone, right? So if you want to see this, the Visual Studio is doing all the other intelligent jobs for you. So let me quickly tell you what all the things that I did. Anyway, you can run this video. That's the reason I'm not writing a blog here as a video for you. I have created a dylib client, which is going to create a binary, and I have created a build.rs, and which is going to be just a placeholder. I am not favoring writing anything in this build.rs, whereas I like this way of creating a .cargo and .config, and within this .config you are going to introduce to this cargo.yml. If you encounter links equals pattern counter, you go to this config and look for the respective target triple with any pattern counter, and this is a place where you can search, and in this name pattern counter. So this is equivalent of lib pattern counter dot dylib. So simple, that's it. So now what all we did is, now this dylib client can dynamically link this pattern counter. So in the pattern counter, what we did is, we have already made this is to be a dylib. That's the reason it has created the dylib for Mac, and what is it, lib pattern counter dot so for Linux. Okay, so let me close all those confusing things here. So I'll go to the SRC now, because we had to make this into a client, and let us copy. We are not going to do anything differently in this SRC except for a few things. I am just taking this same logic of take this, and I am going to have this in the main.rs of the dylib client. Now it should complain to me that I do not know where this pattern counter is, right? So that is the first error we are encountering. So now what we are going to do is that this pattern counter is not directly available to you, dear client, it will be available as an extend create. So extend create pattern counter. That's it. So the only difference between a regular client, I mean a rlib client, and the dynamic client is, in the rlib client your pattern counter is as it is being statically available. The compiler can go and it can check that in the target, release and other depths dependencies. Now if it is a dynamic library, you use an extend create pattern counter and then you use this pattern counter dot get frequency. So there is no change between this main.rs and this main.rs. The only difference is here you are directly using as if it is available directly to you. Here you are just hinting that this is available in the externally it is available for this client. So that's what is the difference. Okay, that's cool. Now what's the next step that we are going to do is that we have to now let us release the dylib client and check what happens on the when we are doing these operations. Okay, and during the compilation, so from our target, let me ask the cargo to be verbose here. So what it does is, this is what you are seeing here, -l pattern counter. So it has linked this dynamically. So what we are having is, we are having a dylib client, and if I run this dylib client as usual, it's working and it is asking me where the file name and what the pattern is. Fine, there is no fun here. And there is a tool, O tool, this is a equivalent of LDD of Linux, where you can look into how this linking sections of this dylib client, which is an executable, right? So dylib client is an executable. That's the reason you are able to. That's an executable. That's the reason you are able to do a shell operation here. So let us ask for -l, print the linkers here, and then this dylib client. So it will tell you that it is using internally the lib pattern counter.dylib, and it took it from the target release the depths lib pattern counter. Okay, so can we check what happens to this if we remove this lib pattern counter.dlib directly from this particular place? Okay, so cd pattern counter target release, and it is telling that it is taking this from the DEPS dependencies. So let me remove this. Let us check this now. So this is an indication that it invoked that pattern counter, lib pattern counter dylib during the runtime. Okay, so but there are a lot of things that may come to our mind. So whenever I am offering the idea of dynamic lib is that someone will create me a dynamic library, they will give it to me as a .dylib or a .so file. Should I have to always keep this here in this particular location if I have such a absolute reference to this dylib? So it's not possible for me to judicially use this at all the places. So at every time I have to find where I have to keep this particular dylib, and that will be too difficult for us to manage. So now what we can do in addition to that is, we can offer certain relative paths as a flag during the time of creating this dylib client, that what we are going to do that now. Okay, and before this, we will try to do the same activity for our Linux target. Okay, so in the config of dylib client, in order for this to work for the Linux, then first thing that what we have to have is we have to define for this let's take this, we need anyway a linker, so that is inevitable. So we first keep that linker first, not to create the executable for us. Then we have to create something similar to this. And here instead of Apple, we are going to use this Linux chain. So that this is for the purpose of linking, this is for the purpose of pattern counter. So this is to create an executable. This linker is different and this is different. And where am I going to search for this? This is not going to be the target of release. This is going to be in the different directory. So where it is, now I want the directory where the .so file is. Target release x86. Sorry, it is in target x86 and then it is in release in the form of .so. So target, it is in this format, x86-64 Linux GNU target this and then release. Okay, and you check for this pattern counter in this place when you are doing a linking for the Linux version. That is what is a hint we are offering to the cargo package manager through this. So now let us do certain things here. Now in the same dylib client, what I am going to do, cargo -v build -release -target, and let us provide this target name. So it has created a dynamically linked dylib client, and let us go to this the respective directory. So where I should go to this dylib client target x86-64 and then release, and here I have this dylib client, and let us let me SCP this dylib client of this x86-64 unknown Linux GNU to this place. So this is an rlib client, the Linux already. Now we are going to just pass this dylib client over there. So cp dylib client, and then root.krs4.1. Okay. We got this, and if run this, it is not going to run because the dynamic libraries are not yet copied. So it's telling that the lib pattern counter ISO cannot open short object file, no such file or direct. So now if you use the LDD, which is an equivalent of O2 and dylib client, it will tell you that lib pattern counter that is so not found. Now we are getting into this problem. Now how to tell where to find this lib pattern counter.so. For example, if you copy the lib pattern counter the same way to this location. So this is the pattern counter. Let me copy the SO file to this location. So this is a SO file. Let us again copy this to SAP lib pattern counter.so slash root slash what is this directory test lib. Okay, and now in the box, if we so now we have the lib pattern counter.so. So if I print this again, it's not going to work. But anyway, let us check that dylib client. Still it is complaining that it is unable to link to this LDD lib dylib client. Still it is saying that the lib pattern counter.so not found. So one of the ugliest way to make this to run is we can inform where this lib pattern counter is using this LD library path. Let us first do the ugliest way, and then we'll do the graceful way of making this dylib client to self-discover where this lib pattern counter.so using an rpath, that is a relative path. All these problems probably you will understand that we have hard-coded during the time of compilation and linking that the lib pattern counter is in a directory called a /krs code target etc., which is not available in this machine. So one thing that what we can do is that we can provide env. Please note this, you use this only as an env variable. Don't ever try to export this ld library path, that may create a lot of issues to you. So in other words, don't ever do this ld change this ld library path. I'm just doing this for the sake of making this to work. And here what we can do is that /root /test lib, that is I am just hinting that to find the SO file here, and then /dylib client. So now this is working, but this is not the right way to do this. But the best way to do that is we have to, when we are creating this lib pattern counter, when we are creating this dylib client, we can inform the Rust system to use something called as a relative path called as rlib. But anyway, have this as handy, and my recommendation is not to run a client by putting this LD library path as its environment variable. And what will be very worse is trying to export this LD library path as /root /test lib, and that is also not recommended. Let us do that in a graceful way. So that's very simple. Nothing. We have to add one more flag during the time we are compiling this library. So how to do that is, when this is so when we compile this as cargo-v build -list -target, and it took that this particular pattern counter is available in a particular location, right? And we are literally going to override this as I will supply you something and use this as a reference for your executable. Okay, so the it's more tricky to explain anyway. When you are giving this cargo hyphen v build hyphen hyphen release hyphen hyphen target, what you can suggest to the rust up chain is or to the cargo package manager, you can provide some rust flags. Say this rust flags equals, okay, hyphen c, and what you can do is you can pass something called as a link arcs equals, okay, so rust flags hyphen c link arcs equals, you can pass three items to this. One is hyphen wl and then hyphen rpath, you can provide an optional thing called as a dot lib, meaning when the idea that what you are passing as a hint to this the creator of the executable is that I guarantee you to give the executable, I mean the .so file for this arrangement in a .lib folder in the target machine. So let's check what happens to this. Okay, rest to see is ready. Most probably a very silly error of a space, could be, yes. So this is there is no logic again to this. You have to pass this without any spaces to this, okay, with link which is a hyphen r path comma dot slash lib, don't ever give any spaces in between, okay. And now let us scp this dylib client again and check what happens to that when we port this to the Linux machine. Okay, so let me go to the command prompt again, and this is a Linux box where we have this rlib client and the lib pattern counter.so. Now what we will do is that we will just mv this rlib client to a different location, iteration 1, mv lib pattern client .so to iteration 1, mv dylib client to iter 1, and now what we can have is we do not have anything in this test lib directory, so that it is very easy for us to see what happens now. Okay, and now it's time for us to copy the dlib client and to that desired location, that is to this Linux box. So let us use the same scp client. Okay, we have received that here. Now let us try to run this as usual. So it's asking for, I am unable to find where the dylib client is. So what we can do is, let us again use ldd on this dylib client. It is telling that lib pattern counter.so is not found. We already had this in the itr1 directory, right? So now what we can do is we can create a directory lib, because we have told already in the rpath that I am going to use a .lib, that is from this directory you can look for the so file in this .lib directory. So I have created a lib, and to this lib directory I am going to copy the .so file. So let us go to this guy. This guy is where he is pointing to. Okay, he is a pattern counter guy. So this is having the .so file. Let us use the same as command scp yeah, and instead of I'm copying this to the root test lib, let me copy this to the lib directory. We have a lib directory there. Yeah, we have just created a lib directory, and this should go there. Okay, and if we come here now, if we ldd client, you can see that it is automatically linked to this lib pattern counter.so, because previously it was not available. Now we have created a lib directory, and as we have copied this thing, it has automatically linked to that. So this is a right way of creating a client that with a rpath, so that when the particular SO file is available, the linking will happen automatically. So now if you run this dylib client without passing any environment variable, this works. Okay, so ls-lra, what we are having is we have a dylib client, and within this lib directory we have this lib pattern counter.so. Both these files are too huge. They are not really adding any value to you, but the idea here is that this is how you can make one client or one module to avail the service of another module dynamically. So the way that we can, if we still look into both these things, let us first strip all. We got this to be reduced by some small space, and this is the, let's try to strip off the lib client. This will also reduce considerably, but that is not very remarkable. If you compare this dylib client with what we are having already in the ITR1, that has this rlib client. So this is around 284968, and the one that what we are having here, the dylib client, this is 645560. So really there is no use of doing this linking through these measures. So the idea of doing a dynamic linking is that I want to shed the amount of logic that this dylib client is carrying, which is nothing but the lib pattern counter.so. So it seems that the linking is not really very beneficial here. The statically linked rlib client is still, it is super slim than this dylib client. This dylib client is at least 3 times than this, right? Or at least 2 times. So what's happening really here is that the dylib client is carrying lot of weight, which is unnecessary for this situation. So what you can do is that you can do some more optimization here. That is, you can pass one more parameter called as preferred dynamic linking as another parameter here. So only when you are providing a preferred dynamic link as another parameter along with this, then probably there is a higher chance that you can make this to reduce. So let us add one more parameter here. REST-C flags. -C, what is it? Prefer dynamic. We pass this as an additional parameter. Okay, what's saying is we have to do the same thing for the pattern counter also. That is, when we are creating this pattern counter, when we are putting a cargo -v build target relays, we have to do this not only for this particular dynamic dylib client, we have to do the same thing for the pattern counter as well. So let us do both. Let us pass this additional parameter of rstc-flags to both these guides and check what happens to the situation. So let us use this command prompt. It's pointing to this pattern counter, and okay, now I have reached this pattern counter directory. Now cargo -v build -release -target. I'm going to pass this thing. In addition to that, I'm going to pass one more parameter here. That's a rust flags that has this prefer dynamic. So by default, it is not preferring the dynamic. Now let's do it. Just close this quotes. So it has created a .so file. Let us look into that. cd target td x86 and release. So we have a new SO file. Now the size of this is very slim, 34/264. It seems it is missing something. Okay. Now let us execute this command again. So clear and execute this command for you. Any issues? Okay, -gnu. Now it's creating perfectly another thing with an additional parameter of rpath is /lib, and it's using this pattern counter, and it considered our C prefer dynamic. Okay, and shall we copy this thing as we did already and look for if there is any changes in the size? Okay. So as usual, we will have our this is a Linux thing, and let us move all this dylib client to a different place for comparison. itr1 dylib client. Sorry, okay, itr2. And this lib is the one that what we are having as part of the itr1. So let me move this dylib client. Sorry, this lib pattern .so /itr2. So let me remove this because I had copied that already. So in the itr2, we have the dylib client and the lib pattern counter.so. This will be useful for us to compare the changes in size, and in the ITR1 what we are having is our regular rlib client and the initial dylib client. So all these things will be useful for us later to compare the change in size. So this is a place we are again going to copy all our things, and within the lib I am not expecting anything. It is empty. We'll copy those the two dynamic library client and the .so file into the individual directories again. Okay. So if I go here, this will help me to, what is this directory? This is dylib client. So first we'll copy the dylib client to test lib. Fine. And then we'll copy this a pattern counter, and this so file will copy this to the lib directory. Cool. So if we come here, we have the dylib client 25272, too small, and if we go to the lib, this is also too small. So now it makes sense that this dylib client is free from lot of other stuff which it carried in the ITR2. So go to this ITR2, probably can check the size of this dylib client and the lib pattern counter with what we are having now. But if there is such a very small size, then the common sense says that we are missing definitely something here. So meaning, let us try to execute this thing if it is working. So it is telling that it is unable to open another shared library, libstd. So the standard library is missing here. So if we use LDD dylib client, the lib pattern counter is linked successfully. There is no problem here, but it is complaining that I am unable to find what this libstd is, where this libstd is. This libstd is nothing but it is what it is giving all the intelligence about the rest of us to this dylib client. So this is one of the reasons why we will not prefer dynamic linking of traits, because making this to work is very cumbersome. It is not very intuitive. So we have to, when we are creating this in a straight tile way, there is no space advantage for us. But when we are going in a prefer dynamic, it is doing all these things, but it is expecting you to give this particular information dynamically. Okay, so this is not a very nice idea. So the advice from my side is all these things may be very useful for the experimentation purpose, but reality, whenever you want to interoperate between two Rust components, please link that statically. The computer is very heuristic here, and it can take what is best for your situation. If required, probably you can go for strip and strip off. Okay, now I cannot close this without showing you how to make this to run. Again, we will go for this ugly route of setting this LD library path. And before this, let me just tell you where you can find this libstd. Okay, so if you put a rust c, and if you put -print sysroot, so this will give you some information about the raster toolchain that what we are having. In essence, that is what is missing in this place, libstdb, etc, etc, etc. So you are going to use the same ugly command of env ld library path, and you pass this as a either as a variable here, or what you can do is that you can use a dollar symbol to pass this in to dynamically evaluate this information, and then this should be available in the lib directory. So in other words, let us try to cd this slash lib. So there is a directory, right? So this is a place, this particular libstd is available. libstd-b6b blah 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 stuff is available. Okay, this is what is required for this executable to run. So instead of I'm giving this the path of this directly through any hard coding techniques, what I am doing is that I am providing this as a dynamically evaluatable symbol using this LD library path. So this will be in the /o test lib path. So from here what I am going to do is I am going to make this env LD library path equals, and this may change from system to system. In fact, for Mac machine stuff, you are using an LD library path, then probably you have to put YLD library path, I believe. We'll check that later. Is something that I have to provide here, and then I have to call my .dylib client. So one thing that what I can do here is that instead of I'm hard coding things, I will simply put $rust C -print sys root and then /lib. So this will evaluate to the place where the sys root of this rust C is, and within the /lib directory probably you can find the .so file. This dylib client is missing. That's it. So this is working fine. Now if you want to check this, let us put this glass and we'll use a lamp here, and this is working fine. So this is the end of the dynamically linking a Rust component to help you understand how two components can either statically collaborate or dynamically collaborate. During the dynamic collaboration, please note that there are two things you have to provide. One is this command, rust flag. You have to tell that you prefer dynamic, otherwise it will take a non-dynamic route, and then you have to pass certain arguments to this to tell where you can find the library that what you are offering through the cargo.yaml in the target machine. So this is someone had told that it is relative to the executable. So if your executable is in X location, and within that from that location, if you are putting this S1 in lib directory, that will be linked automatically. Then the rest of the commands are as usual: cargo, build, release for this target. So to get this rust flags, prefer dynamic and avoid -fl rpath, all these things, it took me to understand this thing or to discover how to make this to work. It took around 3 hours for me over the internet. I guess this exercise may help you to use your situation if you come across with this. It is just few characters: rust flags equals -c prefer dynamic -c link args WL comma -rpath comma where you are going to keep your .so file, and don't put any spaces here. Most of the time whenever you are encountering any errors, just look for if you made any clerical mistakes here, and that's all. And in the next episode we'll discuss about how to use a different flavor of this thing called as a cdylib. This is a dylib, and this pattern counter is offered as a dylib here. I have not seen in my life anywhere the dylib is really used, but I have introduced this to you to know the ecosystem, how you can pass rust flags, how you can create a .cargo directory, how you can put a config and what are things that you can offer that in the config, how to provide the target and how to provide the target pattern counter, how this is linked to your cargo.2ml in the form of links. And this is the essence of the linking operation which we are going to use when we are really building a cross language interoperability. That is when we are using a Python client to invoke the functionality of this particular method, things will be very easy. In fact, it is very easy to dynamically call a function that has been created in Rust from a different language than from Rust itself. Because from Rust, there is no reason for you to go and dynamically call something. You can very well use a crate to do this. So, this is one of the toughest thing because it is all about, there is no logic here. It is all about passing different parameters. Okay. Thank you. We'll talk in the about the cdylib and how to make a Python to talk to the Rust client in the next episode. I guess the next episode is going to be the last episode for the FFI. Thank you so much for watching up to this.